tutorial video is about triangle similarity, and there are two types: side-side-side similarity and side-angle-side similarity. Triangle similarity works like this. If two triangles are similar, even though one might be bigger and one might be smaller, all of the corresponding angles should be congruent. So, for example, this angle should be the same number of degrees as this angle, and this angle should be congruent to this angle, and this angle should be congruent to this angle. So if this is 40 degrees, for example, this would also be 40 degrees, and so on. So all the angles, the corresponding angles, are congruent. On the other hand, obviously the corresponding sides, like 4 and 6, are not congruent. They are something that we call proportional. That means if we made a fraction or a ratio out of each pair of corresponding sides, it should all turn out to be the same number. So for example, if I take corresponding sides 6 and 4, that reduces down to 3 over 2. If I pick another pair of corresponding sides, 9 and 6, make a ratio out of that, again, that reduces down to 3 over 2. If I take another pair of corresponding sides, 12 and 8, again, that reduces down to 3 over 2. So that's what we mean when we say the corresponding sides are proportional. That means if you make ratios out of them, you'll get the same answer every time. Now, when we talk about the two ways to show that triangles are similar, one way is called the side-side-side similarity. Meaning, we don't need all 6 pieces of information. We don't need to know that all 3 pairs of corresponding sides are proportional, and that all the corresponding angles are congruent. We don't need all 6 pieces of information. Side-side-side refers to the fact that we only need 3 pieces of information. In this case, just the corresponding sides are proportional. So if we know this information, that the corresponding sides are proportional, then automatically the triangles are similar, and we can conclude that the angles are also congruent. Okay? Now, on the other hand, we have side-angle-side similarity. That means, again, we don't need all 6 pieces of information, the sides and the angles. We need 3 pieces of information. We need 2 pairs of corresponding sides that are proportional, and the included angle. So for example, so here I'm showing 2 pairs of corresponding sides, and here would be the included angle, the angle between them. Alright, so let's say that this is 80 degrees and this is also 80 degrees. This would be enough information for us to say that the triangles are similar. We have 2 pairs of corresponding sides that are proportional. In other words, and I guess I will do it the other way. It doesn't have to be big over small. It could be small over big. So if I take my corresponding sides, 4 over 6, all right, that gives you 2/3, and take another pair of corresponding sides, 6 over 9, that's 2/3. Because they make the same ratio, that again shows that they are proportional. So those are the S's, my 2 pairs of corresponding sides. Now the included angle, we don't have to do any math, we just look at it and see, oh, they're both congruent, or they're both 80 degrees. So that's 2 sides, and the angle in the middle being congruent. That's enough to know that the triangles are similar. So even though I don't know what the other sides are, I know that they are proportional. Even though I don't know what these other angles are, I know that the angles are the same. So that's a 5-minute lead-in. Let's go ahead and see if we can answer some questions. Triangle RST is similar to triangle RYX by the side-side-side similarity theorem. Which ratio is also equal to RT over RX and RS over RY? Alright, sometimes it helps to put some colors on here so we can see the triangle. So we have this small triangle here, and that is similar to the big triangle, which I will outline in blue. Okay, so we got the small triangle and the big triangle. So when they say RT over RX, okay, so RT is a side of the big triangle, and then that's over RX, which is the corresponding small side. Okay, so we've got a big and a small that are corresponding. And then they have RS. Okay, so we did RT. Now we're doing RS. Okay, so we've got RS is big, and then over RY, which is the corresponding small side. RY. Okay, but if we're doing side-side-side similarity, alright, then we need to go ahead and deal with the other pair of sides. So what's missing? So we've been doing big over small. So let's just keep going and do that one more time. So far we've done this side and this side. So the only big side that's left is this big old side over here, ST. So we'll go ahead and do ST. And of course, what is the corresponding small side? Because we're doing big over small. Well, the corresponding small side would be this guy right here, YX or XY. Alright, so this is the third ratio that we would need to also be equal. Alright, so let's just find that. And that seems to be right here. ST over YX. So there you go. Alright, let's keep going. Consider these two triangles. Which statement is true? Before I even look at these, the question is, are they similar? Let's see if we can prove them similar using side-side-side. So let's start with side-side-side similarity and see how far we get. Let's match up all the smallest sides. So I see 8, 9, and 12. So the smallest side is 8. So let's see, corresponding. Looking at the bigger triangle, I see 32, 36, and 48. 32 here would be the smallest, so these would have to be corresponding. Okay, now the next bigger side would be 9 over here. It's not the biggest, it's kind of the middle-sized one. And the next bigger one here would be the 36. So those, if they're similar, those would have to be corresponding. And now let's go for the biggest, which is the 48 and the 12. So the colors show the sides that would have to be corresponding. So if we're going to do side-side-side, we're going to make all three ratios and see what we get. Now it doesn't matter if you do big over small or if you do small over big. I'm going to do the small over big this time. Again, it really doesn't matter. So I'm going to do 12 over 48, and I'm going to see what I get. So I'm just going to reduce this down. So in my calculator, 12 over 48, that reduces down to 1/4. Alright, let's do the blue ones now. So let's go 8 over 32. Alright, you know 8 goes into 32 4 times, right? So obviously this is 1 over 4. So far we have a pair of sides and another pair of sides. Let's see if we have all three. Let's do the pink ones. 9 over 36. 9 over 36. Again, this reduces down to 1. Oh God! This reduces down to 1/4. So, we have 3 pairs of sides that are proportional. So, we can prove that these are similar by side, side, side. What about side, angle, side? Well, if we were going to do side, angle, side, then we'd need an angle, a congruent angle. So that could work. Since all the sides are proportional, we could just as easily have done the pink side and the blue side, because those are the sides that have the angle in the middle. Alright, so we have the pink sides proportional and the blue sides are proportional, and the included angle is congruent. So that's side, angle, side. So we could have proved that these triangles were congruent, similar, using either of the two methods, side, angle, side, or side, side, side. Okay, now let's answer some questions. The given sides and angles cannot be used to show similarity by either side, side, side or side, angle, side. Well, that is false, as we have shown. The given sides and angles can be used to show similarity by the side, side, side similarity theorem only. Nope, it's both. How about side, angle, side similarity theorem only? Nope, it's both. How about both side, side, side and side, angle, side? Yep, that's the one. And there you go. Okay, consider these two triangles. Alright, looks like we have 3 pairs of angles that are congruent based on the markings. Alright, now how can the triangles be proven similar by side, angle, side similarity? Okay, so if we're going to go for side, angle, side, of course we need 2 pairs of proportional sides, but then we need the angle that is between them. So it's all about coloring. So we have XY proportional, how do I say this? We have corresponding sides XY and VU. Alright, so we have XY and VU would be corresponding. And then let me switch colors. We have corresponding sides YZ and VW. So here's YZ and VW. Alright, if those are the sides, the included angle has to be this one right here and this one right here. So the included angle would have to be angle V and angle Y. Alright, V and Y. But then look what they say. U is congruent to X? No, it needed to be V and Y. It had to be the angle in the middle. So that first one is a no. Try again. Sorry. Okay, let's go again. The next one, we have UV and XY. So here's UV would be corresponding to XY. Whoops. UV and XY. And then we have WV is corresponding to ZY. So WV is corresponding to ZY. All right? And again, if that's going to be what it is, if these are the sides, then the included angle would have to be this one and this one in the middle. It has to be V and Y. And here we have V is congruent to Y. So that's what it is. That's it. This is the one. I don't even have to look at the rest. Right? Well, unless maybe there's more than one right answer. I better look at the rest just in case. Better look at the rest just in case. Yeah. Okay, so looking at the rest just in case. UW is corresponding with ZX. Switching colors now. XY is corresponding with WV. All right, you know what? Let's be very careful about this. I'm seeing a trap that is coming. So let me rewind a little bit. This triangle is on the left-hand side. So we have the left triangle, and then this triangle is on the right-hand side. So we have the right triangle, left and right. So this first ratio, UW over ZX. All right, UW is the left triangle. And then ZX, well, that's the right triangle. So we did, so this was left over right. But then, look what happens. XY over WV. XY is over here on the right. And then WV is over here on the left. So they switched it up on us. Okay? They went right over left. It's upside down. So this is nonsense. If you're going to have the ratios be equivalent to prove similarity, it's got to be in the same direction. All right? If this one is going to be left over right, then this one also has to be left over right. You have to do it the same way both times. So even though the angles are the correct angles, all right, let me erase some of this so we can see. The included angle would be here, and that would be W and X. And they do have W and X. This is still no good because of the way they switched it up. Left over right, and then all of a sudden they did right over left. Look back at the one that we said was good. Look back at that one again. Okay, let's look back at it. We had UV over XY. Okay, so here's UV, all right, which is on the left, and then we had XY, which is on the right. So we did left over right. And then we had WV, all right, and this is WV, and that's on the left again. And then we had ZY, which was on the right. So we had left over right and left over right. So that one was okay. So that's just another thing to watch out for. Okay, now let me erase some of this because it's in my way. All right, last one. Let's check it out. Last one. XZ. Okay, XZ is here on the right. Got to pay attention to that. And then we have WU, which is over here on the left. So we went right over left. And now we have ZY, which is here. Okay, that's on the right again. and then WV, which is on the left. So that's fine so far. All right, right over left, that part looks good. So let's just see if it's the included angle as it needs to be. So this would be the included angle between the blue and the pink. And this would be the included angle, again, sandwiched in between the blue and the pink. So we should be talking about W and Z being congruent to each other. They have Z, but they do not have W. They have U instead, so that's why that's a no. Okay, now we have explained that very thoroughly, why this is the only correct answer. Okay, let's keep going. In the diagram, DG is 15, as you can see. EH is 12. And DE, where's DE? Alright, DE is 8. To prove that triangle DFE, alright, here's triangle DFE. Okay, triangle DFE is similar to triangle GFH. Okay, so here's triangle GFH. So we want to prove that the big blue triangle is similar to the small pink triangle by side-side-side similarity theorem. Okay, using the information provided in the diagram, it would be enough additional information to know that, and then we got some stuff here. Okay, so look, here's what we need to know. If we want to do side-side-side similarity, okay, so we want to do side, side, side. We're going to need 3 pairs of corresponding sides, and they all have to give us the same ratio. So let's see. I'm gonna go small over big. So see the little 5 here? If so that would be the little small 5. So that would be like 5 over. Now the big, all right, would be this entire side would be 20. 5 plus 15, so 5 over 20. All right, that reduces down to 1/4, by the way. So far, so good. Now, if we want to do another side, like say this side right here, I'm going to put a little X here. That's something we need to know. If we're going to do side-side-side similarity, all right, like they said, we'd want to do X over 8. Okay, and this X, so it has to be 1/4, right? So let's see, what would that be? Well, 8 is double 4. All right, so let's see. So that means if I'm multiplying this times 2, then this must be multiplied times 2 as well. Okay, so this X, if you will, must be 2. Okay, that X must be a 2. Because then that would reduce down to 1/4. Like 2 over 8 would reduce down to 1/4 if you cut it in half. Okay, so this GH would have to be 2. And what else? What else? This other side here. Maybe I'll use X again because I'm finished with it. Imagine that this was X. So that would be the little small side. So it would be X over, and then the big side. Now here comes the tough part. the big side would be the sum of these two, 12 plus x. All right, so it'd be 12 plus x. And somehow this has to equal 1/4. Man, this is the trickiest part. But I'm going to go ahead and solve this thing right now. Because this has to turn out to be 1/4. If I did some kind of, if I wanted to solve this equation, I would cross multiply. So I would do 4 times x, all right there, and then I would do 1 times 12 plus x. 1 times 12 plus x is just 12 plus x. Or I could write x plus 12, same thing. I would solve this by subtracting x from both sides, so now I would have 3x is equal to 12. And then I would divide both sides by 3, and I would get x equals 4. Alright, so now I know that x is equal to 4. So that makes this little hf here be 4. Now think about it. So now this is now 4, and this is 12 plus 4, which is 16. Right? And of course 4 over 16 does reduce down to 1/4. So now I have everything I would need. This is what would have to be true if I were going to prove these similar by side, side, side. Now, so let's look back. So HF is 2 units. No, it should be 4, so that's not it. HF is 3 units. No, it's 4. HF is 4 units. And GH is 2 units. Yeah, that's the one. There it is. HF is 3 units. Nah. All right, that was a tough problem, but that's kind of how you would do it. Now, I guess you could have, like I solved the equation here. To do it, I guess you could have done trial and error. You know what I mean? I guess instead of solving equations like I did, you could have taken each one at a time. So you could have said, okay, HF is 2, so you could have put a 2 there. GH is 3, so you could have put a 3 there. And then you could have checked these ratios to see if they equal 1/4. Like the top one we know. 5 over 20 has got to be 1/4. So when you went to check the second one, 3 over 8, okay, for example, if this is a 3, so you would do 3 over 8. 3 over 8 does not equal 1/4. So right there you would know that that one's not it. Okay, so you could have done it by trial and error that way as well. Alright, this is the last problem. Which would prove that these triangles are similar? Check all that apply. So remember, we're looking for side-side-side similarity, 3 pairs of corresponding sides with the same ratio, or side-angle side similarity. That's where we have 2 pairs of corresponding sides, same ratio, and 1 pair of congruent angles between them. So, looking at this first set of ratios, it looks like they're trying for side, side, side. So just let's see if they're lined up right. So we have BA corresponding with XY. So here's BA, and here's XY. Okay, so BA, so that's left over right. Okay, BA over XY. So we just have to make sure that that part matches up. So now when we do this next one, BC, okay, again that's on the left, over YZ. And that's on the right. So far so good. All right, one more. AC over XZ. Again, left over right. That's cool. So that would do it. All right, that's side-side-side similarity. 3 pairs of corresponding sides making the same ratio. All right, so the first one is good. Now the second one, it looks like they're going for side, angle, side. All right, because we have 2 pairs of corresponding sides and 1 pair of congruent angles. Now, these are the same sides that we mentioned before, BA over YX and BC over YZ. So it's these ones. So it's just a matter of if the angle is correct. So if these are the corresponding sides, then the congruent angle has to be the one that's in the middle. It'd have to be angle B and angle Y. So this is the wrong pair of angles. So that's why this is a no. It should have been, if this had been B and Y, then I would have put a check mark. It would have been correct. Okay, next one. Again, I have 2 pairs of sides and an angle, a pair of angles. So again, we're going for side, angle, side. So let's see. I feel like I should just start over. So we have AC over XZ. So here we have AC over XZ. And again, that's left, right. And then we have BA over YX. Again, left, right. So that part's good. So the angle needs to be the included angle. It needs to be A and X. A and X. Ding, ding, ding. So this is good. That's side, angle, side similarity. So that would work as well. Okay, let's do it again. So we have BA over YX. So I have BA over YX. And then I have AC over YZ. Okay, so, and then I have another pair of sides. Okay, I have BC over XZ. And every time I was paying attention to make sure that we were going left over right, and all 3 of these went left over right. So yeah, that would be side, side, side similarity again. So that's good, just like the first one was good. All right, so that's what we have so far. Let's check the last one. Again, I see 2 pairs of sides and a pair of angles. So if anything, this will be side, angle, side. So let's check it one more time. So BC over XY. So here's BC, and here is XY. Okay, and then we have BA over ZX. So here's BA, and here is ZX. So the angle would need to be the included angle. So it would be this angle that's between and this angle. So it would be B and X. But instead of B and X, we have C and X. So that's no good. So that's why that one's a no. So these are the 3. Uh-oh. I picked this one as being right, but it's really wrong. You know what? I've checked over it again, and I actually think this is a bad question. I feel like these 2 triangles, you know, if this is a true statement, that would prove that these 2 triangles are similar. Maybe they're saying that this would not be the correct similarity statement. The order matters, you know, when you write the similarity statement. If you say ABC and then XYZ, you're saying that A corresponds to X, and B corresponds to Y, and C corresponds to Z. So they said A, B, C, and then X, Y, Z. So see how they're all lined up perfectly. But see how the pink is over here on the bottom, but then this one, the pink, is over here on the side? I think that's why they're saying that this is false, because of the order that these letters are written in. So I didn't know that they were going to do that, go by the order of the congruency statement. So, I would want to argue about that if this was my, if this wasn't a computer, if this was a teacher who had marked this wrong on my quiz, I might take this paper back and say, wait a minute, I know that it wouldn't be the proper congruency statement for this ordering, but technically we are proving that the two triangles are similar. We are proving that triangle ABC is similar to triangle XYZ. We would just need a new similarity statement. All right, so that's the best I can do with that. I stand by my check mark, but if you see a question like this, I guess you're going to go ahead and have to mark it wrong if it's not matching the order that they give you in the similarity statement.